Hi everybody, and this is 4.1 tutorial introduction on momentum, specifically collisions. On this problem, we're going to do a collision problem, and it's going to be an elastic collision, a bouncy collision as 4.1 states, 4.1 lecture states. As always, if you haven't watched the lecture, please do so and make sure you take good notes. But I'm going to show you how to do this problem. So what I always do is I write the necessary equations that I'm going to be working with over here. So momentum, that's mass times velocity. And in these problems, what you're going to be doing is you're going to be comparing the initial energy plus or minus an impulse to the final energy. And if you've noticed from that lecture, during collisions, the impulse gets conserved. So really, it's just going to be the initial momentum equal to the final momentum, and this impulse is going to get conserved. So it's not going to be a part of it. But we'll leave it there just in case. Now, what I also did is I taught you how to storyboard a problem. So in this problem right here, they're basically saying you have a 5 kilogram cart. So you're taking, if they don't have a picture, make sure you draw a picture. So I'm just drawing a car that's 5 kilograms. So it's a toy car. It's moving to the right at 15 meters per second. Okay. And it's going to collide with another car that is 10 kilograms. And it's also moving to the right, but at a slower speed. So this car right here is going to overtake this car, and they're going to hit. And so after the impact, they basically say the 10 kilogram car has a new speed of 20 meters per second. And they're asking, what is the velocity of the first cart after the impact? Okay. Well, this storyboard is this equation in a way. So here's what I mean. So the initial momentum of this first guy right here is the mass of the first cart. So the initial momentum is this entire side right here. This entire side is the initial momentum, Pi. So this whole thing is the initial momentum. Okay, so I'm going to go 5 kilograms times 15 meters per second. That's the initial energy, initial momentum of the first cart. The initial momentum of the other cart, you're going to add that to it. It's 10 kilograms times 10 meters per second squared, right? Now, oops, I probably should have given myself more room. Why did I highlight that whole thing? Okay, hold on a second. All right, moved it over there. Wow, that took a long time. And I don't know why I added a square there, but that's just meters per second. Okay. Now, there is no impulse in this problem. Well, it's balanced out. And in the end, you have this final cart moving at that final velocity plus the final momentum of this cart, which is 10 kilograms times 20 meters per second. I keep adding a square. Okay. So in this problem, you can do it this way, or you could use the storyboard way, but also you should be using this. So this is 15 times 5. We'll just call that, I don't know, what's 15 times 5? What is that? So 15 times 5. So that's 75. That's 75 kilogram meter per second. And this is plus 100 kilogram meter per second. That's going to equal to 5 kilogram V final plus 200 kilogram meter per second. So this ends up being the same thing here. This is 75 kilogram meter per second plus 100 kilogram meter per second, and that's going to be equal to 5 kilogram V final plus 200 kilogram meter per second. So the storyboard ends up becoming this equation. So altogether, this right side is 175 kilogram meter per second, and that's equal to 5 kilogram V final plus 200 kilogram meter per second. Now we're going to subtract this onto the other side, and when we do that, that's going to be negative 25 kilogram meter per second equals 5 kilogram V final and then you just divide this onto the other side, which is going to be negative 5 meters per second is the final velocity. So if we look at this, what we could do is we could do some interesting numbers with this. So what's going to end up finding out is that this is going to end up moving to the left at 5 meters per second after the impact. If we had done this bar chart, we actually probably could have figured that out, right? So before the impact, let's call each box 25. So this small guy had 3 blocks there, and the bigger guy had 4 blocks. In the end, we don't know what this guy is, but we know this is 200. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 blocks. So this is altogether 175 kilogram meter per second. This is 0. And that's going to be equal to positive 200 kilogram meter per second. And this is 5 kilogram V final. Well, how do you get 200 to be equal to? So what do we have to do here to this block for 200 to be equal to 75? Well, you have to subtract 1 block from this, right? And since that block right there is going to be so that's going to be negative 25 kilogram meter per second, but that block is also equal to 5 kilogram V final. Well, that gets you right at the answer very quickly. So here are 3 different ways to build the equation. You could use the traditional method where you define the initial momentum. The first block is traveling to the right, so that's positive 15 meters per second, plus the second block is traveling to the right as well, 10 kilograms times 10 meters per second, and you set it equal to 5 kilograms V final plus 10 kilograms times a positive 20 meters per second. And then you do your mathematics from here. Another way is doing a storyboard. You just write this right here. This is then 175 kilogram meter per second equals 5 kilogram V final plus 200 kilogram meter per second. And then you would just do your mathematics from there. The third way is to actually use the bar charts to actually do it. Okay, so there's 3 different ways to do one thing. Okay, personally, when it comes to collisions, I kind of like the storyboards. It's a little bit clearer, especially with you're using numbers. You're putting the direction on this. What you would have found out that if an arrow was pointing to the left, that would have been a negative. If this was pointing to the left, that would be like negative 10, which would have worked out to 10 times a negative 10, so that would have been negative 100. So There's a lot of ways to do this, but again, please watch 4.1 for more information, okay? I hope this helps. Thank you. Bye.